Hello friends. So today we'll discuss about some asymptotic notations. So my first asymptotic notation is theta of Gn, theta notation. So what is the meaning of theta notation? Theta notation means if I write like this, Fn is equal to theta of Gn. So what does it mean? Fn will lies between C1Gn and C2Gn, where C1 and C2 are two positive constant. Means Fn is sandwiched between C1Gn and C2Gn. It's look like that if Fn is equal to theta of Gn, so this is the C1 of Gn, this is the C2 of Gn, and Fn is sandwiched between, and all three functions are positive function. So now, how do we use this annotation in our algorithm complexity calculation? So let replace Fn by Tn and Gn by n square. So now if I place these two values into this equation, this will look like Tn is equal to theta of n square. So it means, what does it mean? It means Tn will lie between C1n square and C2n square. It means that the complexity of the algorithm, if the complexity of algorithm is theta of n square, it means it can never be below the C1n square and C2n square. It will always lies in the range of n square. Okay, it is always lies in the range of n square. It can never be n, and it cannot never be n cube. It will always be in the range of n square, and C1 and C2 will be two positive constant, but it cannot go beyond that. Okay, so this was the first notation. Now next notation is big O notation. So let's say, so what does it mean? Big O notation says Fn is equal to big O of Gn. So it means Fn will always lie between 0 to Cgn. So big O Gn is the upper bound for this function. It means Fn is positive and Cgn will always be the upper bound of Cgn or upper bound of Fn. So now let's replace Tn by Fn by Tn and Gn by n square. So Tn is equal to order of n square. Tn is the time complexity of your algorithm. If you say your algorithm takes order of n square, so it means your algorithm cannot go beyond the n square. It will be somewhere like from 0, 1, 2, n to n, but till n square. So sometime it happens your algorithm is taking n time. Sometime it can happen that your algorithm takes 2n times. Sometime it happens that your algorithm will take 3n times, but in the worst case it will take order of n square. So it means this is your upper bound. So always your complexity will be lower than the n square. Okay, so big O notation is the upper bound. Now the next notation is omega notation. So what does it mean, the omega notation? Fn is equal to omega of Gn. So it means Fn will always be greater than Cgn. So this is the Cgn of function, and Fn is the upper bound of this function. So we were talking about the omega of Gn. Sorry for interruption. So omega of Gn means Fn is equal to omega of Gn. So Fn will always be greater than Cgn, where C is positive. So here you can see that Fn is always above the Cgn. So let's replace Fn by Tn and Gn by n square. So Tn is equal to omega of n square. So it means the complexity of the algorithm will always be greater than n square. It cannot be lower than the n square. It can be anything after the n square. Okay, so this is the meaning of all three notation. First was theta notation, second was big O notation, third was omega of n notation. So this is our lower bound, this is our upper bound, and this is the sandwich. So if I reorder all three, this will look like omega of n, theta of n, and order of n. So which one is better? if you say that your complexity is theta of n, then this will give the exact understanding about your algorithm. Means your algorithm will be somewhere around in theta of n in all the cases, average cases, worst case, and best case. Every time it will be theta of n. If your algorithm is order of n, so it means it cannot go beyond the order of n and can somewhere between 0 to order of n. And this one, I think this is not the good idea to give the omega of n. It means you will be anywhere after the omega of n. So always try to give the complexity in theta of n, because it will give the clear understanding. So this was the asymptotic notation, and thanks for watching. Please subscribe my channel.